I'm Mrs. Kesters from Walsh High School, and this section is on solving systems by elimination. Now there are three types of ways that you can solve systems of equations. It's by graphing, substitution, and elimination. All right, let's go ahead and get started on this last way to solve systems. So I've showed you a couple examples in the previous sections where you have two lines, something like 4x plus 2y equals negative 6, and negative 4x plus 8y equals negative 24. And now we want to find their intersection. That's what you're doing when you're solving these systems. So what you always want to do when you're working with elimination is line up your x's, your y's, your equal signs, and your constants. All right, now it's all lined up for us here. Now what you want to do is match your coefficients in front of your x's or your y's to be the same number but opposite signs. Now this one's really nice because we see that we have 4x and negative 4x. So what I want you to do, it kind of sounds silly but it's going to work out perfectly, is that you want to add both of these together. So add down. You recognize that these cancel each other out. Then you add down. 2y plus 8y gives me 10y. Negative 6 minus 24 gives me negative 30. Then divide both sides by 10. And you get y equals negative 3. It's that simple. Now again, just like when we had substitution, you get one answer, so we have to find the other one because we're trying to find a point. So go ahead and you can erase that what you crossed out. And you want to plug this negative 3 in for either of the equations for y. Doesn't matter which one. So let's take that negative 3 and plug it into that first one. We have 4x plus 2y, which is negative 3, so 2 times negative 3 equals negative 6. So 4x plus 2 times negative 3 is a negative 6 equals negative 6. Add 6 on both sides, and we get 4x equals 0. Divide by 4, so x equals 0. So my point of intersection is 0, which is my x, comma, negative 3, which is my y. Make sure you always write them in points because that's how you solve these. So 0, negative 3 is my answer. All right, let's try another one where you can't just add straight down. So in this case, you either want to get your x's to look the same or your y's to look the same, but opposite signs. So we have 5x plus y equals negative 1, 4x plus 10y equals negative 10. Now your x's, your y's, your equal signs, and your constants are all lined up. So that's all set. But if you notice, if you just add down, nothing's going to cancel out. And that's what you want to do when you eliminate. You're trying to eliminate numbers. So we either want to get negative 5 and 4 to look the same, but opposite signs, or 1y or 1 and 10 to look the same, but opposite signs. I think working with the y's is easier in this case. So let's go ahead and multiply everything in that first equation by negative 10 because we want it to be the same number in front of this y but the opposite sign. So distribute that negative 10 to every single number, including the constant. So you're going to have 50x, then minus 10y equals a positive 10. Now just rewrite this equation underneath. So you have 4x plus 10y equals negative 10. All right, let's go ahead and add down. 50x plus 4x gives me 54x. Negative 10y plus 10y is gone. So it equals 10 minus 10 is 0. Divide by 54 and x equals 0. All right, let's go ahead and plug that into one of the equations. Doesn't matter which one. Let's go ahead and plug it into that second one since it's a little bit closer. So let's plug 0 in 4x with that one. So you have 4 times 0 plus 10y equals negative 10. 4 times 0 is just 0, so that's gone. 10y equals negative 10. Divide by 10, and you get y equals negative 1. So again, you always want to write these answers as points. So my x is 0, my y is negative 1. So 0, negative 1 is my point of intersection. Alright, that's it for today for elimination. So if you have any questions, make sure you stop in and see me at the math office or email me at kesterse@walshreserve.org. I'll see you in class.